Hi, my name is Vic, and today we're going to learn how to predict the price of Bitcoin using machine learning and Python. Predicting Bitcoin is a little bit harder than predicting the stock market, so we'll need external data, aside from just the historical price. So we'll start by getting data about public sentiment about Bitcoin. We'll combine that with historical market data, then we'll train an algorithm to actually predict tomorrow's Bitcoin price. We'll eventually end up using an XGBoost classifier to actually make those predictions. And we'll end with some next steps that you can use to continue improving the model.
And by the end, we're going to have a model that we can use to predict future Bitcoin prices. So I'm recording this on September 8th, and this is actually the prediction for tomorrow. We're also going to be able to backtest our model and evaluate how effectively it worked on historical data. So you'll be able to have confidence if the algorithm is working or not. Let's go ahead and dive in. So, Wikipedia is an online encyclopedia that you've probably heard of, and Bitcoin has its own page on Wikipedia. This page was created in 2009, and there have been a lot of edits of the page since then. So, if you look at this revision history page, you can see each individual edit is a separate line here, and you can see there are a lot of edits. I think there's about 17,000 total edits here. And each edit comes with a comma where the editor described why they made the edit. So by looking at this edit history, we can do two things. One, we can get a proxy for how interested the public was in Bitcoin. That's based on just the total number of edits. And we can understand some of the sentiment of how people felt about Bitcoin by looking at these comments and analyzing them. So we can use something called sentiment analysis. So if the text is negative about Bitcoin, we can figure that out. Or if it's positive about Bitcoin, we can also figure that out. And this gives us a nice proxy for how interested the general public was in Bitcoin. You can also use a lot of other data sources to be that proxy. So you could use tweets, you could use news articles, or you could use Google Trends as well if you want to add those into your model. So let's jump back and let's actually start coding. So we're going to use a library called MW Client, Media Wiki Client, which is created by people who want to access data about Wikipedia and other wikis. And then we're going to initialize what's called a Media Wiki Client site. So this is a class that enables us to work with a specific wiki site. In this case, we're going to work with the English version of Wikipedia. And then we're going to tell it which page we want to use. In this case, we want to look at the Bitcoin page. So we're going to type out Bitcoin. Let's go ahead and run that. Now what we need to fetch is our list of revisions. So we'll say revs equals list page.revisions. And this is going to give us that big list of edits. So let's go ahead and let that fetch. That's going to just take a second. And once it's done, we can go ahead and take a look at our first revision in the list. And a revision is just a dictionary. It's actually an ordered dictionary, which is a special Python class that kind of works like a list and a dictionary combined. But each of these fields here, like rev ID or parent ID, are actually keys in the dictionary. So we can see that we have data about the most recent edit. This edit happened on September 8th. We actually need our list to be ordered the other way. So what I'm going to do is I'm going to use the sorted function to actually go ahead and sort this in reverse order. So the first entry in the first edit to the Bitcoin page is actually the first entry in the list. And we're going to use the key parameter to do that. So the key parameter lets us customize our sort. And since we have a list of dictionaries, we're going to say use the timestamp field in the dictionaries to sort on. So that's sorting in reverse order. And then we can take a look at the first item in our new list. And we can see that this is back from 2009, March 8th, the first ever edit to the Bitcoin page. All right, now that we have our edits in order, we can actually do what I said before. We can find the total number of edits per day and the sentiment of those edits. In order to find the sentiment, we're going to use a library called Transformers. And Transformers is a great library that lets you use a lot of pre-trained deep learning models. And in this case, we're using a sentiment analysis model. Running this will download a sentiment analysis model. So that may take a little bit just to have that download complete. We're going to write a function to use this sentiment pipeline to find the sentiment of a piece of text. So if a piece of text is, I love you, that sentiment is going to be very positive. If a piece of text is, I hate you, that sentiment is going to be very negative. So we're first going to run our sentiment pipeline function. And we're going to pass in the piece of text. We're going to truncate it at 250 characters just to make it run a little bit faster. And by default, this function takes in a list. So we're going to create a list with text as the only item in the list, and the response will also be a list. So we're just going to take the first element from that response list. And the element is going to be a dictionary with two keys, score and label. So score is going to indicate from 0 to 1 the strength of the sentiment, and then the label will indicate the type of sentiment. So what we're going to say is if it's negative sentiment, negative. I hate holding caps lock and then typing. Or sorry, holding shift and then typing. All right. So what this is going to do is it's going to convert our score to a negative number if the sentiment is negative. So a positive sentiment will be a positive number, a negative sentiment will be a negative number. And you can see we're using this model on Hugging Face. And if you want to use a different model, you can actually click here and check out the various models that are offered. The Transformers library is linked to the Hugging Face hub, where you can find different pre-trained deep learning models. All right, now we can quickly test this function out, and we can pass in the text, I love you. And you'll see we get a positive number very close to 1, indicating very strong positive sentiment. We can check out I hate you, and we get a negative number close to -1, indicating strong negative sentiment. And then let's say I feel neutral about you. Just type about. And this one is interestingly going to give us a negative number. So sentiment analysis is not perfect. There can be false positives and negatives, but it is going to give us a little bit of information about how people feel about Bitcoin. All right, once we have our find sentiment function, we can actually go ahead and process each of our revisions to both count up how many edits happen per day and figure out the average sentiment per day. And the first step in that is to write a really big loop. So we're going to say for rev in revs. So for each revision in our list of revisions, the first thing we're going to want to do is we want to convert our time into a string format just to make it easier to work with. And I'll show you what this means and why we're doing it in just a second. All right. So if we go back up to the first element in our revisions list, you can see that the timestamp is stored as a time.struct time. So this is what's called a named tuple in Python, and it's a little bit hard to work with. So it's essentially a bunch of individual values in a single data structure. We're instead going to convert it to a string using the strf string format time function in the time package. So that'll just turn our date into a nice string. And then what we'll say is if date not in edits, so if this specific date has not been created in our edits dictionary yet, we're going to go ahead and initialize it. And we're going to create two keys, a list of sentiment scores and an edit count. And then we're going to go ahead and increment edit count. Remember that you can have multiple revisions on a single day. So the first revision for a specific day will initialize the dictionary. And then for all subsequent revisions on a given day, including the first revision, we're going to increment edit count. So one entry might be edited 10 times in a given day, for example. And then we're going to extract the comment. And we'll go ahead and pass the comment through sentiment analysis. So we'll say edits, date, sentiments. And remember, sentiments is a list that we initialized earlier up here. So we're going to append find sentiment. And we're going to pass the comment into that find sentiment function. So we're calling this function from earlier and passing in our comment. All right. So this is going to give us a big dictionary called edits, where each key is a date, and then we have the number of times that the Bitcoin page was edited on that date, along with the sentiment of the comments for those edits. Now, sentiments is going to be a list, so we need to actually summarize that in order to turn it into a pandas data frame later and merge it with our market data. So in order to do that, we're going to write another loop, and then we'll loop through the edits dictionary. And what we'll say is if the length of edits key sentiments is greater than 0, so if there were actually comments and we could extract sentiment from those comments, then we're going to basically summarize the sentiment. So we're going to basically find the mean of all of the individual sentiment values for each revision on that day and turn it into a single number. So the mean sentiment. And then we're going to find the percentage of the time the sentiment was negative. So to do that, we'll write a quick list comprehension. If S is less than 0. So this is basically finding the total number of times when the sentiment reflected in the comment was negative. And then we're going to divide that by the total number of comments where we could find sentiment. So this will essentially give us the percentage of comments that had negative sentiment. And if we couldn't find the sentiment for any of the comments, we'll just set it to 0. 0 is neutral sentiment. And we'll say none of the sentiments were negative. Sorry, this is neg sentiment. I've been typing sentiment too many times. And then we'll just remove the original list key in order to avoid a problem where we're trying to create a data frame with a list in the dictionary, right? So in order to create a data frame, we need just a single value associated with each key in these dictionaries. And I'll go ahead and fix a quick typo here. So on this line, the second time I typed sentiment, it should be sentiments. And then once we're finished, we can go ahead and run both of these cells. So I'll go ahead and run this cell and run this cell. All right, this is going to take a little while to run, so don't worry if it's going to take a bit. But once it's done, you can check out this edits dictionary, and you'll see that each key is a date. And in that dictionary associated with that key, you should see 3 values: edit count, sentiment, and neg sentiment. So edit count is the number of times the Wikipedia Bitcoin page was edited on that day. Sentiment is the average sentiment for that day. And negative sentiment is the percentage of edits that express negative sentiment that day. Our next step is to actually convert this into a pandas data frame. So what we're going to say is edits df, edits data frame, is pandas.dataframe.fromDict. And this will take in a list of dictionaries. And what we're going to say is orient equals index, which means each of the dictionaries in our list are a separate row in our resulting data frame. So let's take a look at our edits data frame now. And we can see that each row here is a separate date, and we have our 3 columns for each date. edit count, sentiment, and negative sentiment. All right. So we're going to go ahead and convert our index to what's called a pandas datetime index using the toDateTime method in pandas. And what this does is it turns it from a string into a datetime object. And there's some nice things that enables us to do, which we'll see in just a second. Now, the next thing we need to do is solve a problem. So the Bitcoin price is available every day, right? Bitcoin is continuously trading and never stops. But on the other hand, this data has a lot of gaps. And the reason it has gaps is Wikipedia edits don't happen every single day, right? So when this Bitcoin article was created, there were a few edits at that time. And then we went about 5 months without any edits. And the next edit happened in August. So what we need if we want to merge our data together is actually a data frame where there's no missing values. So what we're going to do here is we're going to say from datetime, import datetime. And then we'll say dates, pandas.dateRange, start equals 2009, 03, 08. And then we're going to say the end equals datetime.today. So this is going to give us a pandas datetime index that goes from our start date until today. So you can see we now have a datetime index with 4,933 entries, and it has filled in all of the gaps that we had earlier. So we're going to go ahead and merge this with our existing edits data frame using edits dataframe.reindex. And then we're going to use a fill value of 0. And what the fill value does is on days where we don't have any data from Wikipedia, we're just going to fill in zeros, which makes sense because on those days there were no edits and no sentiment about those edits. So we go ahead and run that, and we can take a look at our brand new edits data frame. And we can see that we now filled in all of the days that previously were blank. There's one more thing we need to do. We now have a lot of days where there's no edits. But a proxy is useful because it tells us what happened in the last time period. So we're going to actually create a rolling average of the edit count, sentiment, and negative sentiment so that from any given date, we can find out how many edits were there on average in the last month. And that'll give us a good proxy for how much interest there was in Bitcoin in the last month. So what we're going to say is rolling edits equals editsdf.rolling, and the rolling method on a pandas data frame will find for us the moving average. In this case, we want the mean. So we're going to take the mean of from every row the last 30 days before that point. So let's go ahead and run that. And then we can take a look at our rolling edits. And we'll see that a lot of the rows at the beginning have missing values because we don't have 30 days of data previous to those days, right? We don't have any data from February 2009 because our data started on March 8th. So we have 30 rows with missing data. But then after that, we can see that the rolling average worked properly. And to remove those early rows with missing data, we're just going to use drop NA, which will drop any rows with missing values. So we can take a look at rolling edits again. And it looks great now. So we have all of the data we need, and we have created our proper rolling averages. We can just write it to CSV now. So we'll say rolling edits.toCSV Wikipedia edits.csv. And we'll be able to use this when we train our model in just a second. So you can go ahead and run that. All right, now we have our sentiment analysis data, which is essentially a proxy for how the market or how the broader public feels about Bitcoin. We're going to move on to actually predicting using our market data. So I'm going to switch to a new notebook called Prediction Live. And What I'm going to do now is actually download price data for Bitcoin and combine that with our Wikipedia data and then create a machine learning model. So the first thing I'm going to do is I'm going to import Yfinance as YF. Yfinance is a package that connects to the Yahoo Finance API to download financial quotes. I'm going to import the OS package, and I'm going to import pandas as PD. Then what I'm going to do is create a ticker object. Ticker object will download the price history of a certain symbol. In this case, not UTC. I want BTC USD. So it's the price of Bitcoin relative to the US dollar. And then I can go ahead and download that history. And this will give us everything from when Yahoo Finance started tracking Bitcoin in 2014 through to the present. So let's go ahead and take a look at BTC. And this looks a little bit funny, right? I mean, there's not necessarily an open price, a close price, or dividends for Bitcoin, but Yahoo Finance primarily tracks stocks. So it's formatted these columns to really track stocks effectively. We can still use them for our purposes. We'll just do a little bit of cleanup to make them a little bit easier to use. But we have the open price, which is the opening price for the day for Bitcoin. We have the close price, which is the price at the end of the day. All right. And then again, we're going to we're going to convert our index to a date time index, because converting it to a date time index makes it a little bit easier to work with because these values really are dates. So let's go ahead and do that. And then we'll delete a couple of our extraneous columns. So we'll delete the dividends column. Dividends doesn't really make sense for Bitcoin. And we'll delete the stock splits column because, again, stock splits aren't really a thing Bitcoin does. And then I like to do this just to make it a little bit easier to work with. But these column names all start with capital letters, and it's kind of annoying to always hold shift and type the letter out. So I'm just going to convert all of the column names to lowercase. You don't have to do this, but I like to do it. So this is just a list comprehension that will convert all our column names to lowercase. And then what we can do is we can go ahead and just make a quick plot looking at our closing price against our index. And our index is just a date. So we're going to plot by day, what did the closing price look like? And yes, we probably should have bought Bitcoin before 2021 when it exploded in price. But you can see the price history of Bitcoin here. Then we're going to want to combine our Bitcoin data with our Wikipedia data. So let's go ahead and read in our Wikipedia data. So we'll read in our Wikipedia edits.csv file that we created earlier. We're going to say index column equals 0 because that first column in our CSV file is our index. And then we're going to say parse dates equals true. This is automatically going to turn our index into a date time index. And then we can take a look at our Wikipedia data. It's the same data we just saw in the other notebook. And then we can merge our data sets together. So we're going to merge our Bitcoin price data with our Wikipedia edit data, and we're going to merge them based on the index. So saying left index equals true means use the index in the Bitcoin data frame. Right index means also use the index in the Wiki data frame. And the index is just the date. So we're basically merging both data frames based on the date. And if we take a look at our combined data frame now, we removed a lot of the earlier rows. So the Wikipedia data started, if you'll remember, in 2009, but our Bitcoin price data only started in 2014. So we ignored those rows where we couldn't find a match between both data frames. But we now have our full data from 2014 through 2022, including our Wikipedia data and our price history data. Okay. Now, one of the most important parts of a machine learning model is figuring out what to predict. what we're going to predict is, will the price go up or down tomorrow? It's really tempting to try to predict the actual price, right? In just in dollars, what is the price of a Bitcoin going to be? The problem with that is when we're using this model in the real world, we usually want to use it to figure out if the price will go up or down. And sometimes when you're just trying to predict the absolute value of the price, the model can actually get you really, really close. So the error metric will look really good if you're using something like mean squared error. But on the other hand, it's not going to directionally tell you the right thing. So you could buy Bitcoin, the model could look awesome, but even though it's really close to the actual price, it could tell you to buy when the price is actually going to go down. So we're just going to look at the direction of the price. Will the direction go up or down? So we're going to first create a column called tomorrow. And what this is going to do is it's going to take the closing price and shift it back one day. Spelled tomorrow incorrectly. There you go. Fixed. So let's go ahead and take a look at our Bitcoin data frame. So you can see on September 17th, 2014, our closing price was $457. And on September 18th, it was $424. But you can see the tomorrow column is the closing price for the next day. So this will help us create our target, which is, did the price go up or down between days? So we're going to go ahead and set up our target column, which is just going to be a 1 if the price went up and a 0 if the price went down. So we're first just going to say tomorrow is greater than the close price. This will return a Boolean, true, false, and we'll convert that Boolean to an integer. So if the price went up, the integer will be a 1. If the price went down, the integer will be a 0. All right, and then one last thing before we create our model, we'll just check out the value counts of this target. So as we can see, the price went up about as many days as it went down, and that's actually good. If one was way higher than the other, that would indicate that we have an imbalanced classification problem, and we need to make some special considerations when we train our algorithm, but we don't, so we don't need to worry about that. But this is a really good thing to check when you are doing classification. All right, we're ready for the machine learning part now. We're first going to train what I call a baseline model. It's a model that runs pretty quickly and will just give us a baseline accuracy that we can try to improve on. So the baseline model I like to use is a random forest, because it doesn't overfit. Well, it can overfit, but it's pretty robust to overfitting. It runs pretty quickly, and it's pretty easy to understand the parameters. So we're going to go ahead and initialize a random forest classifier from scikit-learn. We're going to say n estimators equals 100. N estimators is the number of individual decision trees that we want to train. We're going to say min sample split equals 50. This means each individual decision tree should not split its nodes unless it has at least 50 samples. The higher this number is, the lower the performance on the training set, but the less it will overfit. So this parameter helps you avoid overfitting to the training set. And we're going to set our random state to 1. As you may have guessed from the name, random forest involves a lot of random numbers, and setting a random state will ensure those random numbers are generated in the same order, so that if you just run this model twice without changing anything, you'll get the same results. Okay. Then we'll go ahead and split up our data set. So we'll create a train set and a test set, and we will train the model on our training set and evaluate it on our test set. So we'll take everything except the last 200 days to go in the training set, and we'll take the last 200 days into the test set. This data is time series data. It's sequential. So it's important that we don't use cross-validation or any of the normal machine learning techniques to evaluate error, because we need to respect the order of the data. Otherwise, you get into unrealistic scenarios like using data from 2022 to predict what happened in 2018, which in the real world you wouldn't have known. Then we're going to set up a list of predictors. So these are the columns that we're going to use to predict our target. And I like to just specify these. I think it's easier. It helps you avoid data leakage, which is when you accidentally include a column like tomorrow or target in your training data. So we're going to use pretty much all of the columns as our predictors, and then we can fit the model using these predictors. So we're going to use our predictors to predict our target. So let's go ahead and run this. And once our model is fit, we can actually make predictions and evaluate how effective our predictions were. And to do that, we're going to use the precision score. And what the precision score is when your model predicted that this Bitcoin price would go up, when it predicted a 1, what percentage of the time did it actually go up? And the higher the number, the closer the number is to 1, the better. 1 means that your model was correct 100% of the time. 0 means that your model was correct 0% of the time. So we want to get a 1 precision score to have a good model. In the real world, that's very, very unlikely. There's very few models you can build that will be perfect predictors, but we want to get as high a score as possible. Okay, then we'll create our predictions using the predict method. And again, passing in the predictors. And we'll turn this into a pandas series. By default, scikit-learn will return a NumPy array when you run predict. And there's just some nicer stuff we can do if we convert it into a series. And we'll index that series with the test index. And then we'll calculate the precision score between the test target and our predictions. So we end up with 48%, which is not great, right? We could have flipped a coin and done better than that. But we're going to learn how to continue improving this, so it's not a problem. This is just our baseline precision score. All right. Now let's go ahead and actually improve the accuracy of our model. So in order to do that, we'll actually first write a function to do something called backtesting. So here we only figured out our error over the last 200 rows of our data. But that's not a very robust error metric, right? In the last 200 days, something weird might have happened with the price where our model isn't predicting well, but it could usually predict well. So we want to try to get predictions for as many rows in our data set as possible. And we can do that with something called backtesting. Backtesting enables us to respect the order of the data while still getting predictions for as many rows as possible. So to backtest, we're first going to write a function called predict, which will take in our training set, our test set, our predictors, and our model. And then we'll go ahead and fit our model like we did earlier. Actually, we can just copy and paste this model fit code from up top. Then we'll generate our predictions. And actually, we can just copy and paste all of these lines over. All right. So we generate our predictions using the test predictors. Then we turn that into a series. There's one modification we'll need to make here. We're going to name our series predictions. And then our last piece is we're going to go ahead and combine. So we'll write combined equals pandas.concatenate test target and our predictions. And this will stick both our actual values and our predicted values into a single data frame. And we'll say axis equals 1, which indicates that both our target and our predictions will be separate columns in our data frame. And then we can go ahead and return combined. All right, so that's the first function. Then we can write a backtest function. And this is going to take in our data, which is just our BTC data frame, our model, our predictors. It's also going to take in a start parameter, which I'll explain in just a second, and a step parameter. We'll start out by defining a list of all predictions. So what does backtesting do? So let me just scroll up here, and we'll look at this BTC data frame. So we have data from 2014 all the way through to 2022. So what backtesting will do is say, let's take data from 2014 to 2017, use that to predict 2018. Then let's take data from 2014 through 2018, use that to predict 2019, and so on until we have predictions for most of our data set. We can't start predictions at 2014 because we don't have any historical data before 2014. So what start is start defines how much historical data we want to use before we start creating predictions. So 1095 is about 3 years of historical data. And then step defines the period, the amount we want to make predictions for after the start. So we're going to create new predictions every 6 months, which is why the step is 150. So then we say for I in range, start data.shape 0 and step. And what the start, I explained start data.shape 0 is just the total number of rows in our data. We split up our train and test set. So we're going to say train equals data.iloc 0 through i.copy. We do .copy because we want to avoid a pandas setting with copy warning. And then we say our test set is data.iloc I to I plus step .copy. And then predictions equals predict train test predictors model. So this is calling that function we wrote earlier to predict. All right. Then what we do is we can append our predictions to all predictions. And finally, we can concatenate all our predictions together. And this will backtest our model against several years of data. So we don't have to just evaluate the model based on 200 rows. We can evaluate it based on years and years of data. Now, we're going to upgrade our model. So our random forest was good for just a baseline model, but we're going to use what's called an XGBoost classifier, which is just a more powerful machine learning method that can give us slightly more accurate predictions. So we're going to initialize the XGBoost classifier. And we'll again say random state equals 1. We have to pass in a learning rate to XGBoost, and learning rate defines if we want the model to protect against overfitting or not. So the lower the learning rate, the less likely the model is to overfit. And then we're going to specify how many estimators we want. So the way XGBoost works is it trains a lot of individual models, decision trees, like a random forest, but the way it connects them together is a little bit different. So you don't need to worry too much about exactly how it works, but it uses something called boosting to actually connect the results of one model to the next model. And then we're going to generate our predictions using backtesting, BTC model, and predictors. All right, let's run that. And this will take a second because it's training a lot of separate XGBoost models because we're generating predictions for every 6 months. So we're training a separate model every 6 months. And then when it's done, we can actually evaluate our precision score. So what we can do is precision score predictions target, predictions. So this is going to compare our actual values to our predicted values. And we can see that our score here was a little more than 50%. So an improvement from earlier, but not a massive improvement. The next thing we can do to continue to improve accuracy is to add some more predictors. And that's generally the best way to improve accuracy, is to either get more data or generate new predictors that would be informative to the model. So we're going to write another function called compute rolling. And what this function is going to do is find the trend in various columns over the last period. So we're going to define a list called horizons, and we'll define 2, 7, 60, and 365 here. And basically what we're going to do is find the trend in a few different columns over these horizons. Okay, so we're going to specify a list called new predictors. So we're going to carry some predictors over from before, the close price, the sentiment, and negative sentiment. But we're also going to compute some new predictors. So we're going to loop over our horizons list, and we're going to say, let's compute rolling averages. So we're going to create a data frame called rolling averages, which will look at the rolling average over the given horizon, and then we'll pass in min periods equals 1. And we saw earlier when we used the rolling function that we get a bunch of NA values at the beginning of the data frame. What min periods does is it avoids those NA values by saying, hey, even if you only have 1 period worth of data, compute the average for that 1 period. And before we could do it because we had Wikipedia data from way back in 2009, but now we don't want to throw away a whole year worth of data if we don't have to. All right, and now we're going to find the ratio between the current close price and the historical close prices. So first we'll specify column names, and then we're going to say BTC ratio column equals BTC close divided by rolling averages close. And what this will do is it'll find the ratio between the current close price in the row and the close price over the last 2 days, 7 days, 60 days, and 365 days. So this will give us give the model rather a good idea of how the price is trending. Then we'll go ahead and do the same thing, but for the number of edits to Wikipedia. So this is a proxy for, is interest in Bitcoin increasing or decreasing? So we'll do the same thing, but we will look at rolling averages edit count. And then we'll do one last rolling average. So this is going to be the general trend. So we'll have to recompute rolling here. We'll say closed equals left, min periods equals 1, dot mean. And the reason we're doing closed equals left here is we actually are going to use the target column to determine the trend, the average number of days that the price went up versus down in the last 2 days, 7 days, 60 days, etc. But we have to say closed equals left because we don't want to include the current row. You don't want to include the current target in the rolling average of previous values, because what that can do is give you information about the target. And that's something called data leakage. You don't want to use the actual target value you're trying to predict when you're generating rolling averages or any other predictors. So closed equals left basically says leave the current row out, only look at previous rows. Okay, and then we'll create a column label there, and we'll say BTC trend column equals rolling target. So the rolling average of the target, but not including the current row, most critically. And then we'll add these into the new predictors. So we'll add the ratio column, the trend column, and the edit column. And then we'll go ahead and return BTC and new predictors. So we'll return our modified data frame with the new columns and our predictor list. So we'll define that function, and then we can actually go ahead and run the function. So we can say BTC and new predictors equals compute rolling BTC.copy. And we have to copy it, otherwise we'll get a lot of setting with copy warnings. All right, so we can take a look at BTC now. So if you look, you see we have columns like trend 2, close ratio 2, edit 7, trend 7. So those correspond to these labels that we created earlier, where we said close ratio underscore horizon, edit underscore horizon. So for each of these horizons, 2, 7, 60, and 365, we have 3 separate columns. One is the close ratio column, one is the edit column, one is the trend column. All right, so now that we have these new predictors, we can actually backtest again using our handy function. So we can say predictions equals backtest BTC model new predictors. All right, so we can go ahead and run that. And then we can compute our precision score again. So we can look at predictions target and the predictions predictions. So this is just comparing our target that we got to the actual predictions that we generated with the model. All right, and then we can check our score once it finishes running. And we can see we're now at 53.8, which may not seem very impressive, but it does mean that our model was correct 54% of the time, almost. So as you may know, if you're correct more than 50% of the time, generally your model can be useful in financial terms. But you may want to continue improving this model. I wouldn't recommend that you trade based on this model unless you understand how the open and close prices work and you tune this model and improve the accuracy further. But if you do look at predictions and you look at the last element in this list, this last element is going to be the prediction for tomorrow. So in this case, as I mentioned, I'm running this on September 8th. So this is the prediction for what's going to happen on September 9th. You can ignore the target column. That just defaults to a 0 for the last day. But the predictions column will tell you if the model thinks the price will go up or down the next day. All right, we did a lot today. We read in data from Wikipedia edits. We downloaded financial data from Yahoo Finance. We combined it all, trained a model, developed a backtesting system, improved the model, and created new predictors. And we ended up with a model that you can continue to build on. So there's a lot you can do to continue improving this. Let me talk about a few of the ways. So I'm going to click over to this sentiment notebook. So we looked at Wikipedia edits as a proxy for interest in Bitcoin, but you could also scrape news articles. There's a lot of Bitcoin news sites. You could look at tweets, or you could look at something like Google Trends and pull that data into the model as well. Additionally, you could find other correlated coins or stock indexes or interest rates, things like that, other economic and financial data that you can then combine in. Like, for example, you could get the price of Ethereum or the US dollar exchange rate to other currencies or the inflation rate or other economic indicators like GDP growth rate. So there's a lot of other data you could pull in to make better predictions. You could also tune this model more effectively. So I didn't do a ton of tuning to the XGBoost model. Let me actually find where I defined it. But you could try tuning some of these parameters to see if that improves anything. So those are a couple of ideas for how you can continue to improve this model. You can also use this to predict other cryptocurrencies. So where we downloaded the price, you could change this to something like ETH if you wanted to predict a different coin. Note that you would also have to change the sentiment analysis, although I assume Bitcoin sentiment roughly correlates with sentiment around other cryptocurrencies. You may need to change this to the Wikipedia page for the other currency. All right, so those are a couple of things you can do to improve this model. I hope you enjoyed this walkthrough.